When you think of space launches, you think of fire, smoke, countdowns, and liftoff. But none of that happens without this 6 million-pound beast crawling quietly across Florida. Meet NASA's Crawler Transporter, the unsung hero that carries rockets the size of skyscrapers, slowly and carefully, to the launch pad. Today, we're going deep into the engineering, history, and future of this colossal machine. A machine so big it has its own roads, its own buildings, and even its own weather rules. Grab a snack. You're about to meet one of the most extraordinary machines ever built. Let's start with the basics. The Crawler Transporter isn't just big, it's absurdly big. Length, 131 feet. Width, 114 feet. Height, 20 to 26 feet, depending on lift. Weight, over 6 million pounds. That's about the same as 1,000 adult elephants, or 15 Boeing 747s. It rides on 8 tank-like tracks, each with 57 shoes. Each shoe weighs 2,000 pounds, as much as a rhino. Top speed, 1 mile per hour loaded, 2 miles per hour empty. Fuel consumption, around 125 gallons of diesel per mile. It has two 1,065 horsepower engines, plus 4 generators. So yeah, it drinks fuel like a dragon with a diesel addiction. So what does this monster actually do? The crawler's job is simple, but incredibly important. Move fully assembled rockets from the vehicle assembly building to the launch pads. That sounds basic, but here's the challenge. These rockets can be over 300 feet tall. They're full of sensitive equipment, and tipping them even a few degrees could be catastrophic. So the crawler does the impossible. It carries these giants over 4 miles of specially made gravel roads, all while keeping them perfectly level. That includes the Saturn V rockets from the Apollo era, every Space Shuttle mission, and now NASA's SLS rockets for the Artemis program. Now let's talk about the Crawler's Road, because even that had to be custom built. It's called the Crawlerway, and it's about 130 feet wide, made of 2 parallel lanes. Between them is a grassy median, like a really chill highway for mega machines. It's filled with Tennessee River rock, because this special rock won't spark when crushed. Safety first, especially near rockets filled with fuel. Beneath the rocks, layers of limestone, sand, and packed soil engineered to support the extreme weight of the crawler. And the slope, the road to the launch pad has just a 5% incline, but that's still enough to require the crawler to auto-balance itself as it climbs. It has onboard laser leveling systems and 16 hydraulic jacking cylinders that adjust the platform in real time, keeping everything within half a degree of level. Back in the early 1960s, as NASA was preparing for the Apollo program, it realized something critical. How do you move the Saturn V, the most powerful rocket in history at the time, safely to the pad? Cranes wouldn't work. Assembling it on site? Too risky, so they designed the crawler. It was built by Marion Power Shovel Company of Ohio, starting in 1963. The first one, CT-1, was delivered in 1965. They actually built 2 identical crawlers, CT-1 and CT-2, to ensure there was always one ready to go. Cost back then? About $14 million each, which is over $120 million today when adjusted for inflation. The crawler made its debut with Apollo 4 in 1967 and has been a workhorse ever since. After the Apollo missions, you might think the crawler would be retired. Nope, it was retooled for the Space Shuttle era, which ran from 1981 to 2011. But with the Space Shuttle came new challenges. Different weight distributions, new launch structures, and frequent use. The crawler kept up with regular maintenance and upgrades. Then, in the 2010s, came the next evolution. NASA's Artemis program and the SLS rocket. SLS is even taller and heavier than the shuttle stack, so the crawler needed major upgrades. New rollers and bearings, upgraded control systems, hydraulic system overhauls, and even more fuel efficiency, relatively speaking. These upgrades took years, and the crawler passed every test, ready to serve into the 2030s. Let's step inside. The crawler is run by a team of engineers, operators, and technicians. About 30 people on a typical move. There are control cabs on either end because it can drive in both directions. Operators monitor speed, tilt, fuel usage. Wind conditions because yes, if the wind is too strong, the rocket move gets delayed. Even light gusts can destabilize a rocket. There are crew compartments inside complete with air conditioning, backup power, and communication systems. It's basically a mobile command base that moves slower than your grandma in traffic. The crawler is more than just a machine. It's a symbol of NASA's commitment to detail, safety, and planning. It shows that behind every 3, 2, 1 liftoff, there are months of slow, careful movement. It's helped send astronauts to the moon, launch satellites, run the shuttle program, and now it's taking us back to the moon and beyond. And what's incredible, this 1960s machine is still relevant today, still doing the job, still vital to the mission. So next time you watch a rocket soar into the sky, remember the slow-moving giant that carried it there. The crawler doesn't make headlines, it doesn't go to space, but without it, nothing would ever leave the ground. If you enjoyed this dive into NASA's hidden engineering marvels, hit like, subscribe, and comment below. Would you ride the crawler if you got the chance?